This is 5 questions. The purpose of this video is to provide you with some sample questions that you might encounter in your next test. Okay, for this one we're going to solve for x, and I want you to note that the degree here is 4, which tells us that we're going to have 4 answers or roots. And since we're already given one answer, that 3 is a root, that means we really only have 3 to go. Since we're going to be using synthetic division, let's first examine our equation here to make sure that we have all the terms. Counting down, we have x to the 4th, 3rd, 2nd, 1st, and then x to the 0. So we have them all, which means this. We're not going to have any zeros here in our setup. Now you notice that I wrote 0 here for the remainder, and that's because we know what number we're going to be plugging in immediately. We're going to be plugging in 3, and since we know ahead of time that 3 is a root, that implies that the remainder is 0. So while working this out, if we don't get a 0 remainder, we know we've made a mistake somewhere. So to kind of go through, remember that synthetic division means that we're going to add here. So 2 plus nothing is 2. And then we take that and multiply that answer by 3. In fact, all values down here multiply by 3. So 3 times 2 is 6. And then take 6 and put it over to the next column. And then go ahead and add again. And then the cycle kind of repeats. We get 1, and then 1 times 3 is 3. And then we're going to add again. And I'll just finish this off. Note, we should be getting again 0 as a remainder. So if we don't get a 0 remainder, we know we've made a mistake somewhere. Okay. So that's the result. And keep in mind that the degree of the original problem was 4, so we should be going down 1 degree whenever we do synthetic division. It's always 1 less. Also understand that with this answer, we also have to remember that x minus 3 is a part of this, and that's because 3 is a root. So if 3 is a root, x minus 3 is a factor. If you take this and multiply it to this polynomial, you should get the original answer. So if you want to go ahead and check that, go ahead, though it's really unnecessary. Also, I strongly recommend against that because you're really going to be undoing all your work. Okay, we want to keep going here, and we can do this by either using grouping or rational root theorem. Grouping is a quicker method than rational root theorem, and unfortunately it doesn't work for every single third degree polynomial. So we always try to group first if we can, and then if not, then we use the second method. The reason why we want to use this as a last resort is because it can be rather long. For example, you have the prospect of using synthetic division again, and that would mean just simply writing out the coefficients. Hoping for a remainder 0, we would have to plug in the correct number here to help us attain that. We would generate that list by using the last value, negative 16, and the first value, 2. Numbers that divide into 16 would be written on the top. So 1, 2, 4, 8, and 16 all divide in. On the bottom are the factors of the first number, the 2. So 1 and 2. And then what you would get is you'd get all these different combinations. 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1, 1 over 2, etc. And keep in mind, it's all plus and minus. So that means that you have a multitude of possibilities here. For example, you could try negative 1 and then see if it worked, and then if not, then you would move on to another number. In any case, a very long process just to get one answer. So let's see if we can group first. Grouping means that we're going to take 2 terms at a time and find the greatest common factor. Then we take these last 2 terms and also get the greatest common factor. If the first term here in the second set is negative, as we see here, then you'll want to extract the negative out as well. And that's what we get. And this looks good here. Notice that we have the same binomial, 2x plus 1, twice. So we can go further and finish up the grouping. And then we can use the zero product rule, which says that we can take each group and set them equal to 0 and solve. So the x squared minus 16 gets set to 0, and we get plus or minus 4. Do the same for 2x plus 1, and we get negative 1/2. And that finishes off the problem. So our remaining three answers were negative 1/2, and positive 4, and negative 4. And remember, that's in conjunction to the 3 which we were given. Okay, now let's look at this one. I want you to note that there is only an x variable, but no y. So we're going to be graphing this on a number line. First thing you'll want to do is you want to make sure that right-hand side is already 0, and we've got that taken care of already. Okay, so let's take that left-hand side and fully factor it. The top factors to give us x plus 1 and x plus 1. The bottom gives us x minus 3 and x minus 1. Now we're going to need those because then what we're going to do is we're going to apply the zero product rule to find those boundary points. What that means is this: you take each of these binomials and you'll set them equal to 0. Never mind the arrow for now. So x plus 1 equals 0, and by the way, we got that twice, so no need to be repetitious. X minus 3 is 0, x minus 1 is 0, and that's what we get. So let's take these three numbers and then plot them on this number line. Now you'll notice that these are closed dots. These are totally solid, and the reason being is because of the fact that we have an equal sign right here. However, you should note that on the bottom we want to avoid 0, because if you get 0 for this group, or if you get 0 for this group, we wind up with a fraction that's undefined, which means we need to avoid 3 as an answer and 1 as an answer. So this point and this point here, they should not be solid. They in fact should be open circle. Okay, now that we've done that, what we need to do now is we need to figure out where we're going to shade in this thing. The boundaries are set by those three values, so you're either going to shade here, or here, or here, or here, or some combination. So let's set up a chart. Now with the chart, what we've done is we've listed all the binomials, and yes, this is a rather complex fraction in that, you're timesing up here, then taking this value and dividing by this big product here. However, we don't really have to worry about that here, and the reason being is because of the magic of 0. What we're going to do is we're going to plug in some numbers here, and we're going to test each region. And we only want to test to see if the answer comes out to be positive or negative. And you'll notice right here it says less than or equal to 0. So what we really want is this: does the answer in the end come out to be negative? So let's try that out. Let's take a number that is in this region. It doesn't matter, any number really, whatever makes it easy. Try negative 2. Now if you plug in negative 2 here, I don't even have to calculate. I know the answer is positive. In fact, I know it's positive in every region. And the reason for this is easy. You see, the power is 2. So consider, when you square anything, the answer is always positive. It doesn't matter what you plug in. Okay, well, what about these others though? Well, it's not so automatic, so we're going to have to do a little work here. Plug in negative 2. If you get negative 2 here, and then minus 3, your answer will end up being negative. Yes, it's negative 5, but I really only care if it's negative. Try the same thing down here. Negative 2 minus 1 is also negative. Now consider, whether you're multiplying or dividing, the rules for signs are always the same. So if you have an even number of negatives, and we do here, that means that the end result is going to be positive. So, is that what you want? No. And because of that, we're not going to shade in this region. Let's apply the same reasoning to this region. 0 looks like a logical number to test. We don't need to test 0 here in this first binomial. So what about x minus 3? 0 minus 3 is negative. 0 minus 1 is also negative, and a negative gives us a positive, which again is not what we want. So no answer here. It is common for a lot of students to think that these alternate, whereas, oh, I don't shade in here, so I know I'm going to have to shade in here. Not necessarily the case, and that the fact that we got a squared binomial there does clue us in that something different is going to happen. Okay, testing this region here, we try, say, 2. Plugging in 2, 2 minus 3 is negative, 2 minus 1 is positive. Answer, therefore, is negative. So we want to shade in this region. And then test a value over here, 4 or 5. Try 5. 5 minus 3, positive. 5 minus 1, positive. Answer, therefore, is positive, because a positive times a positive times a positive is positive. So, in reality, that's the only part that we have for our answer. Okay, so let's go ahead and just write that solution out now. If you're going to write it as an inequality, consider the fact that we actually have a point right here at -1. And we also have this shaded part here, and the way you'd write that is you'd write 1, and then you'd write 3, x in the middle. And since we have a gap between these two areas, it's going to be an OR inequality. So that's how you'd write it. If you're going to be using interval notation, then of course we have -1 again. And then we have this interval from 1 to 3. And with the gap you can put OR here, or you can use a different symbol, U, for union. And that finishes this problem.
Okay, that ends this first part. Now move on to part 2.